this is the second class of our system design series. Here we will discuss what the system design is, why it is important, difference between functional and non-functional requirements. For that things, first of all, let's imagine the situation that tomorrow morning you wake up and suddenly become the owner of huge restaurant in your city, like for me it's Lahore. So what will happen? This huge restaurant is that here thousands of customers are coming every hour. So now answer me one question: will one person be able to manage all the things like taking order, managing cash, washing the dishes, and delivering the order? Of course not. So here you will do what? You will divide the responsibilities. You will do what? You will divide the responsibilities, like some people will cook the food, some people will manage payments, they will be known as cashiers, some will deliver food, they will be known as food deliverers, and so on and so forth. And so most important thing is that after dividing the responsibilities, you will do ensure what, that all these parts are synced together to make a smooth system. For example, taking order, preparing food, caching, all should be synchronized so that the system can scale, system can fulfill the needs, and the client should be happy. This planning structure and organization is exactly what system design is in software engineering, that you ensure, as in real system you have a clear roles, smooth workflows, and results in happy customer. Similarly in software engineering, ensuring that systems are well defined, and there is a communication between services like database, cache, and all these services definition and synchronization and the communication will result in scalable system. Today's video we are going to understand system design from absolute scratch, not with boring definitions but with real life analogies, software examples, and interview level understanding. And by the end of the video you will confidently answer some of the most frequently asked beginner system design interview questions. Let's get started. Now let's come towards the first beginner level interview question of system design, that what is actually mean by system design. So if we divide the word of system design in two parts, then you will see that there are two parts. First one is the system and the second one is design. So actually what is system? We know that system is the collection of more than one thing. Like in our body there is a like digestive system. What has happened in digestive system is that there are different organs like stomach, intestine. All these organs are responsible for doing one thing, one job. That one job is digestion of food, actually absorbing the food into the blood. So this is the system. That system is what? Nothing but a collection of elements or organs to perform one task. To perform what? Single task. So and what is mean by design? Well, design is mean by actually making planning, or actually building a blueprint. So what is mean by design? Design means by doing making blueprint before implementation. So actually before implementing system we actually make a blueprint, or you can say an architecture on a paper, that how our system will work. So now come towards our real definition of system design, that system design is nothing but a collection of elements like database, front end, back end, databases, queues, cache, that how these units or how these elements will interact so that our system should work smoothly, and our customers should become happy. So this is the definition, that is the process of defining the elements like front end, back end, cache, and their interactions to satisfy requirement. Like in WhatsApp, we have to design all these elements, front end, back end, to do to ensure what to so that users can message each other, can share content with each other. So that is actually system design is. So system design is nothing but a blueprint of a software system. Here we actually do what, we will plan the system, and like an architect plans the blueprint for a house, similarly system design engineer actually make the blueprint of a system, that how should our system respond to one user, or how should our system responds to multiple users. So for example, before companies like YouTube, WhatsApp, Netflix, or Uber, before these companies write their code, they first do what, they decide what are their components, or how will users communicate with these components, where the data will be stored, how will you manage the million of users, how will you handle them, what happens if servers fail. So all these if buts are actually covered in system design, and this entire process is covered in system design. Let us understand the system design definition or concept with the help of a real life analogy. Suppose we have to build a new university campus. That is a system, right? Yes, it is a system, because in university campus there are multiple departments. Like if you are going to make like IT university, there should be department of data science, department of cyber security. So there should be a connection between them, right? Even if a connection, aside connection, there should be a well formed decisions, like where our classrooms would be in building. Second, where our parking would be in the campus. Second, where electricity lines will be present, so that smooth electricity should be in building as well as in parking. Second of all, we have to ensure the security of entire campus. Imagine if any of thing is not planned, then what will happen? Yes, you are right, everything will collapse. Like classes, what will happen is that classes would overlap. Yes, and second of all, what will happen is that if you do not ensure parking, then what will happen is that traffic will not be managed, traffic not handle, traffic would not manage. Okay, second of all, if you do not decide the electricity wiring, then what will happen is that electricity would fail, electricity would what, would fail in the future. Second of all, if you do not ensure security, then what will happen is that students will suffer, would suffer. Okay, same thing happens in our software system, that without system design, applications would become slow. And second of all, systems will crash, scaling would be impossible, and bugs would not be identifiable, maintenance becomes painful. That is why system design is important, and that are actually the whys of system design, like scalability, maintainability, reliability. Remember, SMER. Okay, so and now let's come towards another concept of system design, that in system design, as I said earlier, that it is nothing but the collection of different elements and interaction and actually the communication between different elements to perform the business requirement, or to perform a business goal, as I said in the early definition. But that elements is known as services. So actually we can say that it is actually, system design is actually the planning of creating different services that will communicate or interact with each other to perform the business requirements. So for example, let us consider that we have to make a blog, like a code system where a user can create code, and when manager create code, it should be broadcasted to the multiple users. Consider this system code, real-time code system. So here what will happen is that whenever a admin user will create a post, this is admin user, and whenever this admin user creates on this, click on this create button, so what we'll do is that we will create a request, HTML request. That HTML request will be sent to the server. Okay, and what will happen is that it will be stored in actually you can say database, and when it is successfully created, then after creation we will have a service that will broadcast this code to the all subscribed users. That will do what? That will broadcast towards the subscribed user of this admin. Okay, so here we can see that actually we have three services like application service, this service application service, and this one is database service or data service, and this one actually a notification service. So actually we divide our this real-time code system, we divide our real-time code system into three services. Into three services. So that is what I want to say here, that consider a Netflix system of Netflix actually do what it will actually. In Netflix there will be a services like authentication service, like recommendation service for recommending different playlists or seasons, billing service for billing the user, streaming service to ensure perfect streaming. So what I want to say, that we actually divide our systems into services so that we can manage, we can manage our system, we can manage our system, we can scale our system, we can debug or maintain our system, and we can improve our system in the future. Again, consider that analogy of restaurant. Consider this, that this chef, you consider if there is a one chef only that is handling customers, that is handling payments, then he will be burned out. The case with our software systems, that we divide our systems into multiple modules or services, and there is a team for each service, and that each team will manage or maintain that particular service or a component of a system. Let's come to a second beginner friendly system design question that might be asked is, what are functional requirements? So actually functional requirements are the features of our system. It actually defines what our system should perform, whereas non-functional requirements is how well our system should perform, and it includes scalability. So now let's come towards example of system of consider example of WhatsApp. In WhatsApp, what are the functional requirements? Think for a while. Yes, you are right. We have to ensure that two users can message each other, and second they can share images with each other. Okay, and second they can call with each other. They can do what? They can call with each other. Now let's come towards, for example, consider another system like YouTube. In YouTube, what are the functional requirements? Function requirements is actually uploading a video. Yes, am I right? Yes, uploading a video. Second, streaming is another functional requirement, that user should be able to stream the videos. So streaming, uploading video, and consuming video, comments, liking, subscribing. So these are the functional requirements. Come towards another interview question of a beginner friendly system design interviews that might be asked is what are non-functional requirements. So non-functional requirements are ensure that how well our system will perform. For example, consider this that in function requirements we will say what will the system do, but in non-function requirements how you will be focusing on what how. Similarly, for example, user can reset a password, and then in non-function requirements you have to ensure that system can reset the password within 3 seconds. How well? 3 seconds, not 5 seconds, not 10 seconds. And function requirements are testing with the help of functional testing, and they are with the security testing. So and I'll keep in your mind SMER: scalability, maintainability, reliability, and efficiency. Apart from these, also performance means the speed, like 2 seconds for password resetting, not 5 seconds. Performance, security, and availability also comes under non-function requirements. Again, come towards our example of YouTube, that in YouTube, if videos are taking more than 5 minutes to open, will users stay? No, definitely no. Similarly, in WhatsApp, if a user send a message and message does not reach or reach in after 5 seconds, will user trust WhatsApp? No. If the messages are not encrypted, and then will users stay in WhatsApp? No. So that is why so software should not only work, it should work well. That is where non-function requirements shine. See the last question of the beginner friendly system design interview, like what is the difference between high level design and low level design. So well, as I said earlier, that design in system design we actually do planning of how our system will work. Yes, so there are two level of designs: high level design and low level design. In high level design, as I said earlier in my earlier post, that system design interviews are unpredictable. In an interviewer can order you to create a high level architecture diagram of a particular scenario, or he or she can also focus on particular services and can ask different questions, trade-offs, and advantage and disadvantages of different things. So we should have a particular knowledge, strategies, and practice to ace these interviews. So now let's come to a difference, that what is high level architecture. High level architecture is nothing but the big picture architecture, as I described earlier in real time code system. As I draw an architecture diagram, so here actually we create an architecture diagram. That architecture diagrams will be having a different things like servers, databases, APIs, how front end and back end is communicating with our APIs, services like notification service, like data service, and scaling strategies like load balancers, auto scaling group, and target groups. So these things, it is a high level architecture. You can say it is a diagram. High level architecture is a diagram involving different components and communications, that like how our system will behave or act. Now let's come towards the second, low level design. So low level design, as the word says, low level means uh, implementation details. Yes, you guess right. Implementation details, like how you will implement either the functional requirements or non-functional requirements. So it is actually involving like classes, like methods, like object relationships, and design patterns. So these are the things that are included in low level design. And simple analogy is that high level design is how the city will be planned, whereas low level design is actually how each room in a house will look like. So actually how the university campus will be planned, like there will be electricity, there will be security guard, there will be how the rooms will be managed, whereas that how each room of a building will look like, how it will look like, it will be aesthetic or not. So this is the implementation detail. We are focusing on one thing, one niche. Now let's wrap up our this video, and let's have a quick review. We study that what is a system design. Actually system design is a collection of components or services, that what definition of the components or services, that what services will be there in our system, how they will interact, and to meet the business requirements, and why we discuss why, and we discuss why this system design is important. System design is important for non-function requirements. Remember, SMER. Okay, so then we cover that how system design work, that we create a plan for our system, and we actually try to break our large system into different services, and we focus on each service, and we focus on non-functional requirements of each service, like their scalability, reliability, performance, and function. We do not focus much on function requirements, like which framework, which library you will be using for implementing front end, back end, or AWS. You will be using either AWS or Azure. These are the actually function requirements. So that is now let's wrap up using one example of WhatsApp design system. So consider a WhatsApp design system where a user, this is our user, user is using this WhatsApp mobile, and write a message of hello to his friend. Do what? Writes hello to his friend. So what will happen is that we will use APIs, high level design APIs, and send it to our server. Our server. Okay, I am not going towards application load balancer. That are the further next topics that we will cover in the next lectures, but here consider there is a one server, and it will receive this message. Okay, it has sent, it has received. Now what will happen is that then database will be involved. What thing will be involved? Database. So consider you type a message in a WhatsApp web, and to a user whose internet is not connected. So what will happen is that message goes towards the server, and from server into the database, and then what happen is that consider your friend becomes active. Your friend becomes what? Active. Then what will happen is that notification service will send your message to your friend. It will send your message to what? To whom? Your friend. So this is our fourth step, that it will inform your friend about the message you send. And then what happens is that your friend will receive that message. So actually this is, we have taken a brief overview. Okay, here different services will be involved, like this database service. We can scale this depending upon our users, and notification service we can also scale it. So we have considered this example for one user. Imagine millions of messages are being sent every day, every second on WhatsApp. So here we need what? We need scalable servers, we need distributed databases, and we need what? We need load balancers to fulfill this requirement. So we need scalable servers by auto scaling group. by and distributed databases, not in one zone, in different availability zones, so that if one database is crash, another is present, backup is present in another availability zone. And caching so that we can minimize our database hits. And load balancer, so that we can manage our load. We do not want to send multiple requests to a one server. Why? Because it will crash. So we will use load balancer. And then queues for what? For the asynchronous tasks, okay, like email processing and stuff like that. So that is what system design is, that you actually think or think about systems. Okay, to wrap up, today we learned what actually the system design is. Okay, then why it matters, then what are the function and non-function requirements, how we divide our whole system into the services, then high level design, low level design, and then real world examples. And remember this line forever, that system design is not just drawing boxes, like it is not just creating an architecture diagram. No, it is not. It is not just drawing boxes, it is thinking like an engineer. It is what? It is thinking like an engineer. Like trade-offs, you should be well aware of advantages and disadvantages of each approach. And so in upcoming videos we will talk about scalability and microservices and stuff like that. So subscribe if you want to ace your system design concepts from beginner to advanced. And if this video helped you, please comment that I understand what is system design. And thank you for watching, and I will meet you in the next one.